3 says equal volume of 0.25 molar acetic acid and 0.25 molar potassium hydroxide are combined. Write the net ion equation for the reaction and identify the aqueous species that have the highest concentration at equilibrium. Justify your answer. All right, so what I'm going to do is I have to write the name of these compounds. Okay, so basically I have to write the name of this compound, which is acetic acid, and I have to write the name of this compound, which is potassium hydroxide. Well, acetic acid, because it's ic acid, it's going to come from the acetate ion. And I know the acetate ion is H2C2H3O2. I'm going to put an H in front of it to become acetic acid. Now, I know acetic acid is a weak acid because it's not one of the 6 that we know is a strong acid. It's going to react with potassium hydroxide. Potassium hydroxide is just KOH. And that's going to produce my base, basically, okay, my reaction. So from this, I know this is acetic acid, and because it's acetic acid, I have to write it as H2, as acetic acid, basically. I cannot write it as just the H+, because that would make it a strong. I know KOH is a weak base, which means when this reacts, it's going to separate out into basically K plus OH minus, okay, all right? Which means when this reaction takes place, this acetic acid is going to donate this H to this OH minus. Okay? So that H is going to go over the H minus to make basically H2O liquid, plus the leftover, which is the acetate, which is the C2H3O2 minus, plus that potassium. Now notice that the potassium was here on the reactant side, and here on the product side, which means the potassium is a spectator, so they don't have to be shown. So the correct writing of this equation would be acetic acid plus the OH minus from the strong base makes water plus the acetate. All right? So now I have my equation. So now it says which species exist in the highest amount. Well, I know that I have 0.25 moles of this and 0.25 molars of this. Since I have 2.5 molars of this and 2.5 molars of this, and the volume looks like it's the same, which means I have 2.5 moles of this and 0.25 moles of this. And since the number of H, which is 1, attached to the number of OH, which is 1, it's a 1-to-1 ratio, correct? So by the time I'm finished with this, I will not have any of this left over. Does that make sense? Yeah. Which means how much water I'm going to make, I don't care, because water is a liquid. I know how much of this I'm going to make. I'm going to make basically 0.25 moles of this, because it came from 2.5 moles of the acetic acid. Now, don't forget, what's in here also that is not shown? The potassium. The potassium is also in here. How much of it is in here? Well, we started with 2.5 moles of OH minus, which means we also started with 0.25 moles of the potassium also. So if you notice at the end, I have 2.5 moles of the acetate, and I have 2.5 moles of the potassium. I have no more moles of the acetic acid, and I have no more mole of the H+. So these two species are the highest concentration at equilibrium.